Welcome to 7.4, Special Right Triangles. Our essential question is, how do I use the relationships among the sides, that is the length of the sides, in special right triangles? So we're talking about right triangles here. They have 90-degree angles. And these triangles in particular that we're looking at are special right triangles. And there are two special right triangles. One of them is the 45-45-90 triangle. So you see here that the angles are 45, 45, and 90. This 90 is a right angle. So 45, 45. And the other special right triangle is a 30, 60, 90 triangle, where one of the angles is 30, the other angle is 60, and there's your right angle. So here are our two special right triangles. And we will see this often in construction. I remember also in quilting with my mom making quilts or patterns. Anytime that you're using triangles, it's very common to see these types of triangles. And what we're doing is showing the relationship between the lengths of these triangles. In other words, if we have a 45-45-90 triangle and we have one of the lengths using a special right triangle, we can determine the other lengths of the sides. And the reason we can do that is because of similarity. Remember talking about similar figures? What we're going to do is we're going to create a pattern that will always be true for a 45-45-90 triangle. And that pattern in particular is 1, 1 square root of 2. And for a 30-60-90 triangle is 1, 2 square root of 3. So any 45-45-90 triangle will follow this pattern. And so all we have to do is when we have a problem and we need to solve for lengths of sides, we put our pattern right beside it and then create the proportion that we need to solve for the length of side that we want. And the reason we can do this, let's back up and review this concept of similar figures. Remember, we talked about congruent figures, and congruent figures means that they have the same shape and the same size, or sizes. With similar figures, though, we are saying that they have the same shape. Yeah, that's true, but their sizes are not the same. Their sizes are proportional. So let me review. Let's go back to 6.1 with similar polygons. And remember, the symbol for similarity is just one squiggle. The symbol for congruence is an equal sign with a squiggle on top of it. You will remember that the symbol for approximately is a double squiggle, but a single squiggle is similar. Now, whether the term squiggle is technical, I'm not sure, but that's what we'll say. One squiggle means similar polygons. And like we said, a similar polygon means same shape and proportional sizes. And that was really helpful when we were solving polygons, because we could create this proportion. Remember, we said that x over 4 equals 10 over 5, for example. We also use this in section 6.5, using proportionality theorems. So remember that if we have two or a segment inside of a triangle that is parallel to one of the sides, then we can create a proportion within side of there. The reason for that is because this smaller triangle is similar to the larger triangle. And we can also do this, remember when we had 3 parallel sides and then 2 lines, not sides, but 3 parallel lines that was cut through by 2 lines. In this same way, we could also create a proportion here. And then in 7.3, using right or similar right triangles, remember we had an altitude coming down out of the right angle, and that created three different triangles. This blue on the outside, the medium green, and the baby red on the inside here. And these three triangles are similar to each other, and therefore we could create this proportion amongst their corresponding sides. So same concept that we are using here in 7.4, that all 45, 45, 90 triangles will be proportional with each other. They are similar with each other. They have the same shape, and their sizes are proportional. And the pattern that I'd like for you to memorize is rather simple, is 1 square root of 2. So notice that, first of all, let's flip this thing over like this, and notice that 45, 45, okay, hey, these two angles are congruent. And when you have two angles in a triangle that are congruent, it means that that's the opposite sides of those congruent angles are also congruent. These opposite sides are congruent, like we see here, 1, 1. And so what kind of a triangle is this that has two sides that are congruent with each other? It is an isosceles triangle. And that is my wife calling. But let me try to finish this up. That is an isosceles triangle here. So we have two sides that are congruent because we have two angles that are congruent. And the hypotenuse here is the square root of 2. So let's get a feel for, we know that the hypotenuse is always going to be the longer side. So let's get a feel for what the square root of 2 is. And if you were to plug that into your calculator, it is approximately 1.2. Notice that I've used a double squiggle here because I mean to communicate that it's approximately. There's more numbers that go beyond here. I had to round it off to the nearest tenth. And so you see that square root of 2 is longer, 1.4, is longer than 1. That makes sense, that this hypotenuse is longer than the other two sides. So let me show you now how to use this pattern. Here's a problem that they give to us, and it's a 45, 45, 90 triangle. And so I draw my pattern in the same orientation as the problem. So here's my right angle, and then I have my two congruent sides there, and then I draw my hypotenuse. And then my pattern, the angle is 45. Now, you know also that if one of the angles is 45, then because this is a 90-degree angle, so 90 plus 45 is 135, and the sum of the interior angles is 180 degrees. So if you take 180 and subtract 135 from it, you'll get 45. So you really only have to label one angle because you know the other angle is going to be 45 degrees. So here's my pattern of 1, 1, square root of 2. Square root of 2 is approximately 1.4, so that's the longest side, so that will always be your hypotenuse. And so here's my two triangles now that are similar to each other, and which means that they have the same shape. See how they have the same shape, but proportional sizes. So let's create a proportion. Remember, a proportion is two ratios set equal to each other. And I want to solve for the length of x here. So let's put x up in the top left. And this length, this side here, is or corresponds to what side in my pattern. Here's my problem. And so what side does it correspond to in my pattern? And it is square root of 2. These two hypotenuses correspond to each other. So I'm going to put square root of 2 underneath x, and what other corresponding sides do I know the length of? Well, I'm told that this is 6, and so this and the one side, the side whose length is 1, is corresponds to the side 6 here. So how do they do this? Up on the top, I put the big one, so the pattern and problem. So I need to follow that same sequence, that same pattern there. And so let's put 6 up on top because I went from left to right. Therefore, on this ratio, I also need to do left to right. And so square root of 2, is that right? Wait a second, hold on. No, I almost put square root of 2. So it's x over square root of 2 equals 6 over 1. There it is. So 1 goes here. Sorry about that, I almost goofed up. So there is my proportion. X over square root of 2 equals 6 over 1. Now how do I solve this proportion? I could cross multiply if I wanted to, so I can do that lightly here in pencil. And you could cross multiply and say 1 times x equals the square root of 2 times 6. But I'd rather you think about this and say, wait a second, I want to solve for x, so how do I solve for x? I want to get rid of the square root of 2 in the denominator, so let's multiply both sides by the square root of 2. The square root of 2. Okay, and then here's a fraction multiplying times a whole number, or some kind of a number there. And so let's turn this into a fraction. And when you see the fraction bar, then you think of division. So what is the square root of 2 divided by the square root of 2? Well, it's 1. And so that cancels out on the left-hand side. And we're left with a big invisible 1 on the left-hand side. So x is going to equal 6 times the square root of 2. I guess I'll continue doing it in pencil. 6 times the square root of 2. And that's it. We're done. That's our answer. That's our simplest radical form is what they're asking for. And this is the simplest radical form. The number underneath the radical cannot be simplified any farther. So that is my answer. Let's do another one. Here's a problem. And it is a 45, 45, 90 triangle. And I know that one of the legs is 9 square root of 2, and the other leg is x. Hey, let's go back over here. With this 45, 45, 90 triangle, if one of the legs is 6, what do you think this other leg is? And you are correct. It is 6, because remember, we said that a 45, 45, 90 triangle is an isosceles triangle, so these two legs are going to be congruent. So same idea over here, that if this guy is 9 square root of 2, then this other congruent side is going to be 9 square root of 2. But they are asking for the length of the hypotenuse. So I have to first draw my pattern in the same orientation. Notice that I have my right angles in the bottom here, and then my 45, 45 angles up on the top. So what was my pattern? What were the numbers that I need to remember again with a 45, 45, 90 triangle? It's 1, 1, square root of 2. Square root of 2 is the larger one. That's goes on the hypotenuse. So here's my square root of 2 and 1, 1. So I want to solve for x. Let's create a proportion. So x over something equals something over something. So what side corresponds to the x? It's the square root of 2. And let's pick another pair of corresponding sides that have the numbers to them. And so I went left to right. So let's do again left to right. So 9 square root of 2 over 1. And there is my proportion. Let's solve this for x. I want to get rid of the square root of 2. It just happens that it is using the square root of 2 again. Will not always be that way. So let's multiply both sides by the square root of 2 in order to clear my denominator. And so on the left-hand side I get x, and on the right-hand side I get 9 square root of 2. Let's do that. Go ahead and do that. 9 square root of 2 times the square root of 2. And you will remember, hopefully you know from Algebra 1, that when I have a square root times a square root, I can put it underneath the same square root. And so now I have 2 times 2, and 9. And what is 2 times 2? 2 times 2 is 4. And what is the square root of 4? It is 2. I'm running out of space here. So now I have 9 squared, now 9 times 2, which is 18. Okay, so my x is equal to 18. And my lead is also breaking. So x equals 18 is my answer. All right, and we'll talk more in class about simplifying radicals. So you're ready now to do these problems on your sheet of paper. And I've already kind of drawn your pattern here for you. And notice, though, they don't tell us what the measure of these angles are. But they do say this is a right angle. And they also do say that each of these legs here is x. So therefore, these two legs are congruent with each other. And therefore, the base angles are also going to be congruent to each other. So we know for sure that these angles have to be 45-degree angles also. So I have a 45, 45, 90 triangle. And then I set up my pattern. So in the same way, and here's 1, 1, and square root of 2. Okay, so go ahead and do your proportion. X over what? So x corresponds to what side? Equals, and then what you want to do is pick two sides that both have numbers. So you're going to say x over 1 equals 2 square root of 2 over the square root of 2. And then simplify that guy. And also over here, you're going to do a pattern. And I don't want to give you too much here, but do a pattern. This is 45, 45, 90. And then put your numbers, 1, 1, square root of 2. And you're going to solve for y. So create a proportion with y. Y over what? What is the length of the side that corresponds to y? And then pick two numbers that correspond to each other, sides that correspond to each other. Okay, go ahead and pause the video and do that. Now let's look at 30, 60, 90. Very similar concept. Let's go very quickly. But instead here, for a 30, 60, 90 triangle, the three numbers I want you to memorize are 1, 2, and square root of 3. So instead of 1, 1, square root of 2, you want to do 1, 2, and square root of 3. Now, remember, the longest side is always going to be your hypotenuse. So what is the longest, what's the biggest number of 1, 2, and square root of 3? Well, square root of 3 is actually 1.7, approximately 1.7. So 2 is your longer side, that's your hypotenuse. So when you solve a problem, for example, like this one, and I draw my triangle in the same orientation. Wait, let me do this. Let me just help you out with this one. Draw your triangle in the same orientation here. And here's your 30-degree angle. Okay, so remember, 1, 2, square root of 3. 1 is always across from the 30-degree angle, the smallest. So smallest side is always across from the smallest angle. Here's the smallest angle, so the smallest side goes across from there. And the longest side is always the hypotenuse, which goes across from the largest angle. So here's my largest angle, the 90 degree. This is my hypotenuse. So what side is longer? What number is longer? 2 or square root of 3? And the number is 2. So we put 2 here, and so therefore the other side is going to be the square root of 3. So I want to solve for the value of x. So here is x. Let's create a proportion. X over square root of 3. The square root of 3 is going to go down here. And then I have two other corresponding sides. And it's going to be the square root of 3 over 1. So x over square root of 3 equals the square root of 3 over 1. And then solve that proportion. And then here, since this angle is 90, this angle on the right-hand side is also going to be 90. I want to solve for h. So let's ignore the left-hand side. And let's create a pattern alongside of that. And what's going on here? Hey, all that I know, they don't give me any angles. It's crazy, guys. So, but I do know this is a right angle. And I do know that if this was 30-degree angle, because here's the small, let's do it this way. Here's a smaller angle, smaller side. So the smaller angle is going to be across from that. And if this was 30, then I'd have 1. And then where does 2 go? 2 goes here. Oh, no, wait, whoa, I made a mistake. 2 does not go there. 2 is the largest number. 2 goes on the hypotenuse. So 1, 2, and then square root of 3. And notice that the hypotenuse is always double the size of the smaller leg, and that's the case here. 2 times that, this is my wife calling again. 2 times 2 is 4, and so, hey, therefore, these have the same proportion, and therefore, this is going to be a 30, 60, 90 triangle. So you want to solve for h. So h over square root of 3 equals, you could say either 4 over 2 or 2 over 1. It's going to be the same exact ratio. Okay, hope that's helpful. I got to get back to my wife. May the Lord bless you. We'll talk to you soon.